But we're going to graduate some of these fraction problems to another level. We're going to graduate some of these fraction problems to another level. So let's begin by first talking about something that has nothing to do with math, because I think talking to you for a minute will make the problems that we discuss in a couple of minutes a little easier. I have a pretty big family, and this has nothing to do with math, but indirectly it will have to do something with some of the problems we proceed with in a couple minutes. But I have a pretty big family, and everyone in my family, you might be the same way. They call me something different. My brother calls me Rick. My mom calls me Eric. My uncle calls me Eric Bryant. Some of my family members call me Fathead. It's a nickname. It's they say that in a loving way. But everyone identifies me as by a different name. When I go to school, my students call me Mr. Hendricks. My principal, she calls me Mr. Hendricks sometimes. Other times she'll call me Eric. And all of these names, I respond to all of these names. And depending on the environment, it would be very inappropriate. Even though I respond to all those names, depending on the environment, it would be awkward for example, it would be awkward for me to be identified by all of those names given the environment. What I mean by that is my mom would never call me Mr. Hendricks, even though I respond to that name. My students would never call me Eric because they have a degree of respect for me. They call me by my last name, and they say Mr. Hendricks. So even though I respond to all those names, given the environment, it is inappropriate to use some of those names. One of the keys to dominating math is to be able to acknowledge a number in a variety of different ways. One of the things we talked about, let me backtrack a little bit. I want to say this before I lose this thought. Last week we talked about timetables. Our children need to know our timetables, and I was thinking this week that another area where I think our students missed the boat and math becomes somewhat challenging is when they don't ask questions. There's two things: timetables and they don't ask questions. Let me get back to my previous thought. Our students are going to dominate math if they can say a number in more than one way. And I want to give you a couple of examples. Then we're going to move to a couple of problems. Let's take a look. Let's take a look at what I'm talking about. The number 1 can be written as 1.0. The number 1 can be written as 1.00. The number 1 can be written as 1 over 1. The number 1 can be written as radical 1. The number 1 can be written as 5 over 5. The number 1 can be written as 6 over 6. And I could go on and on and on. My ability, I need you all to listen good today. This is a good lesson today. My ability to say the number 1 in an infinite number of ways allows me the ability to dominate math. And I want you to dominate math as well. If you listen good and if you ask questions, you will dominate this subject. Some of these problems are a little bit interesting, but 5 over 5 is 1. 7 over 7 is equal to 1. 7 divided by 7 is equal to 1. 9 over 9 is 1. There are an infinite number of ways to say 1. Now, depending on the problem, it's inappropriate to use 5 over 5. Just like it's inappropriate for my students to call me Eric. Depending on the problem, it's inappropriate to use 1.0. All right, so we're gonna look at this problem, but I want you to remember that 7 over 7 is 1. 10 over 10 is 1. 126,000 over 126,000 is 1. Anything over itself is 1. Keep that in mind as we look at this problem. I'm very excited. I hope you are too. Let's take a look at this problem. All right, so let's look at 6. We'll come to this later. We'll come to this problem later. Let's look at 6 minus 3 and 2/5. All right, let's look at 6 minus 3 and 2/5. Right now, you can't solve this problem the way it is because the 6 minus 3, that's not a problem. However, you need a common denominator here. There is no fraction up here where you can subtract the 2/5. So you have to do something about the absence of the fraction here. And what you're going to do is remember that another way to say 1 is 2 over 2 or 5 over 5. All right, you're going to have to keep that in mind. So let's take a look at this problem. Another way to say 6 is 5 plus 1. 5 plus 1 is 6. And what you can do is remember that another way to say 1 is 5 over 5. So another way to say 5 plus 1 is 6 is to say 5 plus 1 is 6. All right? 5 plus 1 is 6, but there's more than one way to say 1. You could say 5 plus 5 over 5 is 6. 5 plus 1 is 6, and 5 plus 1 is 6. These statements are exactly the same. So let's keep that in mind as we rewrite this problem 6 to be 5 and 5/5. 6 and 5 and 5/5 is the exact same number. There's no difference between 6 and 5 and 5/5. This is 5, that's 1. Together, 5 and 1 give you 6. But now, a question I have for you, why did I choose 5 over 5? Why didn't I choose 126,000 over 126,000? Why didn't I choose 2 over 2? See, what you have to do is realize that I'm still mindful of what we talked about the very first week we started working with fractions. I'm still mindful of a common denominator. Let's take a look at this problem one more time. The denominator here was 5. That's why I chose 5 over 5. So we have 3 and 2/5. And I had a denominator of 5 here. That's why I chose 5 over 5. Because I know that's equal to 1, but not only is that equal to 1, I have the same denominator here that I had in this fraction down here. So now let's finish the problem. Now we have a common denominator, which is essential. So now you have 5 minus 3, which is 2, and you have 5 minus 2, which is 3, and they keep the common denominator, 2 and 3/5. Final answer. I know that someone has a question on that. And like I said earlier, one of the number one issues that our students have is the timetables, and they don't ask questions when they have them. My experience is a lot of children are very, very social in the hallways, very, very social outside of class, when things are not as important. But when it comes to something important, when it comes to something like understanding their classwork, sometimes our students fall short in being just as vocal, being just as social. I want them to ask questions. So that's one thing where I think our children are having an issue. Another area is these timetables. If you go to these different parent-teacher conferences and the teacher says, well, you have a smart young person, however, they're taking a lot of time to finish tests. They're taking a lot of time to complete an assignment. It's taking them a little bit longer than the other children to complete whatever things they're being asked to do. You might want to check to see if they're able to make these calculations in a timely fashion. It might be an issue with timetables. We did 6 minus 3 and 2/5. Let's rewrite 6. That's 6 over 1. That's 6 over 1. And let's rewrite another way to write 3 and 2/5. You keep the denominator of 5, and you multiply 5 times 3, which is 15. You add the 2, and you get 17. So again, having a mastery level understanding would require you to be able to write 6 in more than one way. One way that we wrote 6 was 5 and 5/5. Another way we wrote 6 was 6 over 1. This is going to be one of the keys for us being able to dominate math. We wrote 6 in two different ways, 6 over 1 and 5 and 5/5. The more comfortable we feel doing this kind of thing, the easier math will be, and the more we'll be able to solve it in multiple ways. Let's finish this problem. The common denominator, we still have to have a common denominator of 5. So because 1 can be divided into 5. You can multiply a number by 1 to get 5. That's why 5 is the least common denominator. So let's multiply the 5 by 1 to get that. And we have to multiply 17 by 1 to get 17. Let's multiply the 1 by 5 here to get 5, and we multiply the 6 by 5 to get 30. So what we end up with is 30 minus 17 now. There is no difference between 6 over 1 and 30 over 5. And obviously there's no difference between 17 over 5 and 17 over 5. Now that we have a common denominator, we can subtract, and we end up with 13/5, which simplifies. 5 can divide into 13 2 times, and if you divide 5 into 13 twice, you get a remainder of 3, and you keep the common denominator, or you keep the denominator of 5, and notice how you get the same answer.